Welcome to today's deep dive. We are unpacking a genuinely bizarre, largely undocumented astronomical anomaly from June of 2020.
Yeah, it's a fascinating one.
Right. So this massive, ultra-dark object appeared near Jupiter, behaved in ways that completely defied our understanding of orbital mechanics, and then it just quietly vanished.
Like it was never even there.
Exactly. To piece this together for you today, we are pulling directly from the data logs of the Outer Solar System Origins Survey, some internal tracking documents, and historical planetary impact records.
We've got a lot of data to get through.
We do. And if you are someone who loves getting straight to the core of a mystery without the fluff, consider this your shortcut. The mission today is to explore this anomaly because, frankly, it proves just how much of our own cosmic backyard remains entirely unmapped.
It really does. I mean, when we pull up a GPS map to navigate a new city, there's an expectation of absolute certainty, right?
Oh, for sure. Every street is there.
Exactly. Every dead end, every coffee shop is charted. You trust that the map on your screen reflects physical reality perfectly.
But imagine looking at that perfectly charted map and a city-sized object just materializes in the middle of the highway.
Yeah, out of nowhere.
It doesn't follow the roads, it is completely blacked out, and then as you zoom in to figure out what you are looking at, it just vanishes.
Poof, gone.
No crash, no trace, just a blank screen. It shatters that comfortable illusion of total surveillance we think we have.
It absolutely does. And to really understand why this June 2020 event is so staggering, we need to set the stage with Jupiter itself.
Right, our giant neighbor.
Jupiter basically acts as this massive, overzealous gravitational bouncer standing the velvet rope of the inner solar system.
I love that analogy. It's just tossing people out of the club.
Pretty much. It constantly flings unruly cosmic debris out into the parking lot or, pulls things into itself. It shields our little VIP section from a constant devastating rain of cosmic rocks.
We owe Jupiter a lot.
We really do.
Yeah.
Gravity is the fundamental law keeping that VIP section safe. Jupiter's immense mass dictates the flow of traffic in its neighborhood. It clears out its orbit, captures strays, and usually that bouncer is incredibly reliable.
Usually. But sometimes a bouncer looks the other way for a split second and something slips through.
Right. And the deep space mapping programs detected something slipping through in the summer of 2020.
So we need to look at the profile of what slipped past. The Outer Solar System Origins Survey picked up this object, and I gotta say, the raw data is wild.
It's completely unprecedented in a lot of ways.
It was massive, easily large enough to be classified as a minor planet, but it was never given an official name.
Nope, no name.
For weeks, it was just a designation, right? Just a database number that most people never bothered to look at.
Yeah, but the few astronomers who did analyze that data set, they started a very quiet, very uncomfortable conversation.
Because it wasn't acting like a normal rock.
Not at all. The object simply refused to play by the established physical laws of our solar system. The first glaring anomaly was its trajectory.
The internal tracking documents described its orbit using this very polite, very sanitized scientific term. They called it non-standard.
Non-standard, which is doing a lot of heavy lifting there.
Okay, let's unpack this, because
Okay.
this is where I need some clarity. I mean, space rocks get bumped off course constantly, don't they?
They do, yeah.
Like they experience the Yarkovsky effect where uneven heating and cooling from the sun acts like a microscopic thruster.
Exactly.
They experience outgassing. They get nudged by the gravity of passing moons. Isn't a shifting non-standard orbit entirely normal for a minor planet?
Well, you are bringing up the standard perturbations. Objects are absolutely subject to the Yarkovsky effect or gravitational nudges, but, and here's the key, we can calculate those.
Oh, because it's just math.
Right. Celestial mechanics relies on Keplerian elements to predict an object's ephemeris. We can plug in the mass, the solar radiation pressure, and the gravitational influence of nearby bodies, and plot exactly where an object will be 50 years from now.
I mean, we predict eclipses down to the second, centuries in advance.
Exactly, the math works. But the degree of deviation with the 2020 object couldn't be explained by outgassing or a simple gravitational nudge.
It was too extreme.
Way too extreme. Its velocity and vector were shifting on a macroscopic scale. It was moving as if it were interacting with a gravitational field we couldn't detect or, carrying a momentum that simply didn't match its estimated mass.
Wow. But even if we could forgive the bizarre orbital mechanics, the optical data presented an even bigger headache.
Oh, the optical data is where things get really weird.
Yeah. It wasn't just moving wrong, it was virtually invisible. The sources indicate this object had an albedo of less than 4%.
And that level of darkness tells a very specific story about its origin.
So, to put that 4% albedo into perspective for you listening, think about fresh, black asphalt on a newly paved road.
That's a great comparison.
That asphalt reflects about 4% of the light that hits it. This object was a cosmic void sneaking through the inner solar system wearing Vantablack.
A Vantablack ninja.
Exactly. But how does an object get that dark?
Well, we are talking about extreme space weathering. When you find an object with an albedo that low, you're usually looking at ancient, carbon-rich material.
Like from the outer edges of the solar system?
Precisely. Out in the deep, freezing reaches of the Oort cloud or the Kuiper belt. Complex hydrocarbons out there are bombarded by cosmic rays and solar radiation for billions of years.
Billions of years of just getting cooked by radiation.
Right, and this irradiation process essentially bakes the surface. It breaks down the molecular bonds and creates this thick layer of tholins.
Tholins?
Yeah, it's like a tar-like sludge that absorbs photons rather than reflecting them.
So finding an object baked that black by the deep void cruising right near Jupiter that is entirely out of place.
Completely. It immediately indicates the object traveled a very long way from a very dark place. You just don't form ultra-dark, carbon-heavy minor planets in the relatively warm, bright neighborhood of Jupiter.
Okay, so just as the tracking programs were monitoring this massive, mathematically impossible Vantablack object, it completely dropped off the instruments.
Poof.
But asteroids drift out of optical range all the time, right? Or the Earth's orbit shifts and the sun blocks our view.
Yeah, that is a standard loss of signal. But this wasn't optical tracking.
Right, because radar was actively pinging this object.
Active radar tracking.
Astronomers calculated its projected ephemeris, pointed the radar arrays at the exact patch of sky where it should have been the next night, and the return was empty.
Nothing but static.
The radar went quiet while the object was right in the middle of the projected field of view.
And that's the kicker. An optical telescope might lose a dark object against the blackness of space, but radar relies on bouncing radio waves off a solid mass.
It doesn't care about the albedo.
Exactly.
Yeah.
If you are blasting radio waves into a specific sector and getting zero return, the mass is simply no longer there.
Which is terrifying. If you are tracking a car on a highway and it vanishes from the cameras, your first instinct is to look for a crash.
Yeah, if it didn't drive away, it must have hit something.
Which leads us to look a little closer at Jupiter's penchant for covering things up. When I was reading through the planetary impact logs for this deep dive, I was blown away by Jupiter's brutal track record.
It's a violent place.
We all know about Comet Shoemaker-Levy 9 back in 1994, where humanity watched Jupiter's gravity tear that comet into 21 separate fragments,
And swallow them, yeah.
leaving Earth-sized impact scars. But the logs show it didn't stop there.
No, Shoemaker-Levy shifted the entire astronomical paradigm. Prior to 1994, planetary impacts were largely considered ancient history.
Like stuff that only happened when the solar system was forming.
Right, events confined to those violent early days. But once we realized these impacts were a modern threat, we started finding them everywhere.
It's wild. In 2009, an amateur astronomer found an impact scar on Jupiter the size of the Pacific Ocean.
And professional observatories almost missed it completely.
Then in 2010, another impact, just a flash of light on Jupiter's edge, gone in seconds.
Yeah, blink and you miss it.
By 2021, we had multiple confirmed impact events in a single year. The sources now suggest Jupiter gets struck by significant objects anywhere from once a month to dozens of times a year.
Which brings us to the mechanics of a gas giant impact. Jupiter doesn't have a solid crust like Earth or Mars.
Right, there's no ground to hit.
The visible surface we see through telescopes is merely the upper deck of a violently swirling atmosphere. As you descend through those clouds, the pressure and temperature rise exponentially.
I read that the hydrogen gas becomes so compressed it transitions into a supercritical fluid.
Yes, and eventually into liquid metallic hydrogen. It's an extreme environment.
But hold on, if a minor planet plunges into that atmosphere, wouldn't we see a massive explosion? Shoemaker-Levy created fireballs that were visible from Earth.
Well, it depends entirely on the angle of trajectory, the structural integrity of the object, and how deep it penetrates before it detonates.
Oh, so it might not blow up on the surface.
Right. A massive, structurally dense object could plunge straight through the upper troposphere on a steep angle. The immense atmospheric pressure would act like a vice.
Like a giant trash compactor.
Yeah, silently crushing the object into vapor hundreds of kilometers below the visible cloud tops.
So no fireball on top.
Exactly. The thermal bloom of that destruction might never break through the upper cloud layers to create an optical flash for our telescopes. It is entirely possible for Jupiter to swallow a minor planet whole, leaving absolutely no trace or visible scar.
And the source documents contain a massive clue regarding that exact scenario.
They do. This is my favorite part.
Monitoring programs actually flagged a brief, highly anomalous infrared reading, a faint spike of heat in Jupiter's southern hemisphere, deep in the atmosphere.
And the timing.
It happened around the exact same time our dark object vanished from the radar.
A thermal signature, perfectly aligned with the disappearance. And yet, no follow-up paper was ever published exploring that correlation.
I understand that a random thermal fluctuation in a chaotic gas giant could just be a coincidence.
Sure, probably isn't the same as definitely.
But the timing is undeniably provocative. If we operate on the assumption that Jupiter swallowed this object, we have a plausible explanation for how it disappeared.
Right, the bouncer took it out.
But that still leaves the biggest question unanswered. What was it before the bouncer swallowed it? The internal documents present several working models, starting with a rogue centaur.
A centaur is a minor planet with an unstable orbit that crosses the paths of the giant planets.
So in this model, the object was a dark, carbon-rich centaur that simply got perturbed into a fatal Jupiter-crossing orbit.
Exactly. It approached the giant and was absorbed cleanly. Occam's razor favors this explanation because it relies entirely on known objects and known mechanics.
But that doesn't fully explain the sudden, clean disappearance without an optical flash. The documents also explore the idea that the object shattered silently before it ever touched the atmosphere.
This model relies on the Roche limit.
The Roche limit, okay.
When a celestial body gets too close to a massive planet like Jupiter, the gravitational pull on the side of the object facing the planet is significantly stronger than the pull on the far side.
Because that side is literally closer to Jupiter.
Right. And this difference in gravitational pull creates massive tidal forces. If the object was structurally weak, perhaps a loose conglomerate of carbon-rich dust and ice.
Those tidal forces would literally pull it apart.
Exactly. It crosses Jupiter's Roche limit and disintegrates. It would have been torn into thousands of smaller fragments.
And individually, those fragments would be too small for a radar to track.
And too small to create a massive fireball when they hit the atmosphere.
Wow. So it would look exactly like the object simply vanished from the radar screen right before impact.
Perfectly explains the vanishing act.
Those are the models grounded in our standard solar system inventory. But the data from the Origin survey leaves the door open for something much stranger.
The interstellar theory.
Yes. The sources explicitly bring up Oumuamua from 2017 and Comet Borisov from 2019. Oumuamua was our first confirmed interstellar object, and it was accelerating in ways we couldn't easily explain without gassing.
It was so bizarre that some theoretical physicists were arguing it might be an artificial construct.
Which is a whole other deep dive. But if we found 2 confirmed interstellar visitors in just 2 years purely by luck, aren't we missing a massive number of them?
Oh, absolutely. You are touching on a massive blind spot in astronomy, which is observation bias.
Because we only see what we're looking for.
Right. We rely on sky surveys like Pan-STARRS and the Catalina Sky Survey, which scan the heavens looking for optical movement against the background stars.
But they're looking for bright things.
Yes. These surveys are optimized to find bright objects moving at standard orbital velocities. If an object is moving incredibly fast and has an albedo of 4%, our surveys are mathematically likely to miss it.
So the fact that we found Oumuamua and Borisov implies the background rate of interstellar objects passing through our solar system is astronomically high.
Exactly. The 2020 anomaly could have been a third interstellar visitor drawn in by the sun's gravity, swinging past Jupiter on its way through the void.
And the tracking data supports that, right?
It does. To confirm an object is from another star system, we look for hyperbolic excess velocity.
What does that mean, practically?
Well, an object bound to our sun's gravity travels in an elliptical orbit. It's trapped. But an interstellar object travels on a hyperbolic trajectory. It comes in moving too fast for the sun to capture it, and it leaves just as fast.
And the non-standard trajectory we discussed earlier.
It perfectly fits the profile of a hyperbolic orbit. We didn't capture enough data points to publish a definitive confirmation, but the math absolutely allows for this object to have been a traveler from beyond our solar system.
Which leaves us with the final possibility detailed in the sources. What if the anomaly was something we simply do not have a scientific category for yet?
Scientists are really hesitant to formally discuss phenomena that lack a theoretical framework.
Nobody wants to sound crazy in a peer-reviewed paper.
Exactly. But the history of astronomy is essentially the history of us realizing how limited our categories are.
Right. Just 20 years ago, we didn't know fast radio bursts existed.
We had no idea.
We couldn't explain these massive, inexplicable pulses of energy from deep space, and we didn't fully understand magnetars, dead stars with magnetic fields so powerful they can strip information off a credit card from halfway across the moon.
That's a great example. We're constantly finding new phenomena that force us to add rows to the cosmic table.
So an anomaly of this scale forces us to rewrite the textbooks.
It does. Whether the June 2020 object was a hyperbolic interstellar visitor, a structurally fragile dark centaur, or something entirely new, it highlights a profound limitation in our current perspective.
We tend to view our solar system as a closed, fully cataloged system.
But the reality is that we are operating with severe observational deficits.
Okay, let's synthesize this big picture for you listening. What does this deep dive actually mean for our understanding of the night sky?
The overarching truth from all these sources is that space is incomprehensibly enormous, and our vision is incredibly narrow. We do not have constant, omniscient surveillance of our own solar system.
We don't have a live CCTV feed of Jupiter's orbit.
No, we only have snapshots. We capture brief moments between cloud cover, limited by telescope allocation time, budget cycles, and frankly, the constraints of human attention.
The universe has had 13.8 billion years to fill itself with matter. Humans have only been looking through telescopes for about 400 years.
It's a drop in the bucket.
We are standing on the shore of a vast ocean, shining a tiny flashlight into the surf and pretending we have cataloged everything that lives in the deep.
That's beautifully put. And the 2020 anomaly was real. It was tracked by radar. It was documented in the databases.
And then it vanished?
It might have crossed the Roche limit and been silently swallowed by supercritical hydrogen. It might have slingshotted into a new, unseen hyperbolic orbit, carrying it back out into interstellar space.
Or it might still be out there, a massive, dark monolith waiting to show up on an exhausted astronomer screen at 2 in the morning.
Which is a staggering thought.
It really is. I mean, think about what this means for you. Right now, there could be dozens of these massive, silent, carbon-baked objects moving through our solar system on uncalculated trajectories.
And they remain virtually invisible.
Because of their phenomenally low reflectivity and our over-reliance on optical surveys, we just haven't pointed our instruments at the right patch of dark sky yet.
We started this deep dive talking about the comfort of a fully mapped GPS grid. We like to think we know where all the hazards are.
We find comfort in the idea that Jupiter, our gravitational bouncer, is always watching the door and clearing out the debris. But consider the reality of the data we just unpacked.
An object massive enough to be classified as a minor planet sneaked into Jupiter's neighborhood entirely undetected until the last possible second.
It behaved completely erratically, breaking standard orbital mechanics, and then it vanished without a single definitive trace.
It's unsettling, to say the least.
It is. If our surveillance is that porous, how confident should we really be in our ability to detect a similar ultra-dark anomaly?
Especially if its non-standard orbit happened to be pointing it away from Jupiter.
And directly toward Earth. Keep looking up.